Here's video number 3 for 2.9, and there's just a little bit more to go through. Talking about complex zeros, there's this thing called the fundamental theorem of algebra, so you probably should know it. It's a polynomial function of degree n, where n is greater than or equal to 1, has at least one zero in the complex number system. Okay, that doesn't really say much. Because any zero is in the complex number system, like the number 2 is in the complex number system. But it's just saying, hey, they have to have a root. Any function that has a degree n, where n is greater than or equal to 1, has to have at least one zero in the complex number system. Okay, and any real number is also a complex number, and that's what I've been saying. Like 2 is a complex number, just like 2y is a complex number, because complex numbers are any number you can write. So let's go remind ourselves about linear factorization. If c is a complex zero of a polynomial function, then x minus c is a linear factor of the polynomial. So that was just like we did for rational ones, right? So nothing new there, except they're now including complex zeros. So let's see what this all means. It says find the zeros of the function, then find the complete factorization of the function. So you're going to find the zeros, and then you're going to write it as linear factors, which I kind of have been doing all along. So, oh goodness, here we go. We have a quadratic pattern, so we're going to let a equal... My cat just jumped up on me, sorry. Let a equal x squared. So we have a squared minus 24a minus 25. So that would be a minus 25, a plus 1. So I have x squared minus 25 and x squared plus 1. So that would be x plus 5, x minus 5, and this is still x squared plus 1. So, okay, this becomes... well, we already have that. This becomes x, we put it equal to 0. So, cat. Sorry. So this is x squared plus 1 equals 0. So x squared equals negative 1. So x is equal to plus or minus the square root of negative 1, or plus or minus I. So we had... What's weird is, instead of writing the linear factorization like that, here's the difference. We're going to keep these because these are normal. You would say that, well, let's put the answer. X equals plus or minus 5 and plus or minus I. All right, we got that. But when we write the linear factorization, we're going to say, well, we can write f of x as x plus 5, x minus 5, and then we write x plus I, x minus I. And so that's the difference. Instead of this, we write it like that. We get down and then we do x minus this number. So that's all. So there's the two answers they want. This one is find the zeros, and this one is find the complete factorization. Sound good? Let's do another one to make sure you're all up to speed. Let's get, well, oh, this is fine. Let a equal x squared. You're going to be good at these, aren't you? Because we have so many of them. So a squared minus 4a minus 12. So that would be a minus 6, a plus 2, or x squared minus 6, and x squared minus 2. So this one is going to be x squared equals 2, so x equals plus or minus the square root of 2. That one was easy, no I. And this one is x squared, because we're setting it equal to 0, equals 6. So you get x equals plus or minus square root of 6. What did I do wrong here? This is supposed to be, okay, look, I made a mistake. That's supposed to be plus 2. So that would be negative 2 here. So negative 2 there. So x equals plus or minus I square root of 2. Sorry, you guys. And I was like, well, we're not getting an I. This one would be x equal plus or minus the square root of positive 6. So our answers are, for the zeros, are plus or minus I square root of 2 and plus or minus the square root of 6. And then to write my linear factorization, here it is. F of x is equal to, and then I'm going to write x plus I square root of 2, x minus I square root of 2, and keep going, x minus the square root of 6, and x plus the square root of 6. So that's how you do that. So it will be all 4 of those terms. So you're using these roots that you got at the very back, or the zeros, roots, whatever. Shall I do one? Cat? Okay, my cat. Okay, let's skip number 3. It's similar. Let's go to number 5. Can we factor that by grouping? I think we can. 4 terms, so I'm going to look for it anyway. Okay. So let's see, take out an x squared and I get x minus 5, and take out a positive 16 and I get x minus 5. So it factors to x squared plus 16 and x minus 5. This would go to x squared, set them equal to 0, equals negative 16. So x equals plus or minus the square root of negative 16, which is plus or minus 4i. And this goes to x equals 5. So our answers are plus or minus 4i and 5. But our factors are x minus 4i, x plus 4i, and x minus 5. Okay? So, I think you got that. Let's do one more, if you need it. One more, and it's going to be a P over Q. I'm going to number 6. Okay? You can't factor by grouping, so we're going to do P over Q, and this is 1. So P over Q, I could say, is plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. Okay, let's see. If I try to reduce that down to see if there's like 1 positive or 3 positive, it goes positive to positive, that's 1, no change. Sorry, no change. Positive to negative, there's my first sign change, and negative to positive, 2. So I have 2 positive or 0, so 2 or 0. So that's not good because it could have 0. So let me see if I do negative x. That would be negative x cubed plus 6x squared plus 14x plus 16. So this is negative to positive, that would be 1, and then positive, positive, positive. So this is better because now I know that there's 1 negative real 0. So I know there's 1. I'm going to check for 1. Okay, so looking at this, I've got some big numbers. I think I'm going to jump. Let's try, I'm looking at negatives, right? So let's just jump right to 4, negative 4. Okay, and that would be 1, 6, negative 14, 16. 1, that would be negative 4. That would be 2, negative 8, negative 22. Nope. All right, that didn't work. So now I am going to go to negative 8. Maybe negative 8 will work. Oops. Negative 8. Okay, 1, negative 8 would be negative 2. That would be positive 16. So that would be a positive 2. There it is, negative 16. Yay, 8 works. So x plus 8 is one of them, is one of my factors. And then this goes to x squared minus 2x plus 2. So does there anything that multiplies to 2 and adds to negative 2? Nope. So let's figure out, I'll do quadratic formula. Opposite of b would be 2 plus or minus the square root of 4 minus 4 times 1 times 2. This is cool. Over 2 times 1. So I'm going to get a negative under this radical. So I'm going to get an imaginary number in my quadratic formula. 2 plus or minus the square root of 4 minus 8 over 2. So 2 plus or minus the square root of negative 4 over 2. And the square root of negative 4 is 2i. So 2 plus or minus 2i over 2. And now we can simplify that to 1 plus or minus I. Okay. So it was, I'm going to erase here so I make myself some room. Okay, that was just me figuring out the 8. I had x equals negative 8 and 1 plus or minus I. 1 plus or minus I. Now, here's when you write the factors, they kind of come out funny because you have to do x minus each one of those. So, the first one we know would be x plus 8. But this one is x minus 1 plus or minus I. So you kind of need parentheses for that guy. Whoops, I did the wrong kind of parenthesis. You got to do a parenthesis to get that whole thing in there. So x plus 8 and x minus 1 plus or minus square root of I. Now you can leave it like that, or you could rewrite them to be this. X plus 8, and then this one is x minus 1 plus I, and this one is x minus 1 minus I. So that's what that looks like. Okay, this is the zeros, and this one is the factorization, the linearization. Okay, all right, so I'm going to stop. That was a long video. Okay, this ends 2-9, so try your homework for 2-8 and 2-9, and I will post how to do the answers. I will see you on Wednesday.